Okay, this is Unit 5, Lesson 1, practice problem number 4. They were asking us to find the area of this figure. So there's really two different ways that we can think about this. I'm going to show you both ways, but we're going to get the same answer for both of them. Okay, so on this problem, the first way that I'm going to look at it is I'm going to look at it as I have a circle, and then I also have a rectangle, and the two are overlapping each other. Okay, so in my circle, it tells us that we have a radius of 3. And so if I use my formula to find the area of a circle, pi times the radius squared, I'm going to take 3 and plug that in for the radius. Area equals pi times 3 squared. So then our area is going to be 9 pi square units. That's the area for the whole circle. Okay. Now, for the rectangle, if I'm looking at my rectangle here, right? Well, I know that for the rectangle, if my radius in my circle was 3, that means that this length right here is going to be 3, right? Because that's just another radius for my circle. And this length right here is also going to be 3, because that's just another radius for my circle. Or in other words, from point C to point D is a diameter for our circle, which should give us a diameter of 6, which means that the length in my rectangle is just 6. Now, using my same circle radius idea here, the height or the width of my rectangle is going to be 3, because that's just another radius in my circle. So if my rectangle here is a 3 by 6 rectangle, then for the area of the rectangle, length times width, we're going to do 6 times 3, and the area for that rectangle should be 18 square units. So now, when I'm using this method, right, we found the area for the whole circle here, and then we found the area for the whole rectangle here. But this half of the circle was counted in both of those places, right? We counted this part inside of the whole circle when we found it, and we counted this part inside of the rectangle when we found the area of the rectangle. Well, we don't need to count that part twice, right? We really just need to count that part once. So what I'm going to do from this point, and this is where we're going to see the two different methods happening. The first method to take care of that is I could take my area of my circle and my area of my rectangle, and I could add those together. So this is the area of the whole figure, 9 pi square units from the circle plus 18 square units from the rectangle. All right, and then I'm just going to grab my calculator. Let's see, 9 times pi plus 9 times pi, there it goes, plus 18 equals approximately 46.27. Now, I still need to remember to subtract out that half of the circle that got counted twice. So now I'm going to take my area of my circle, right, which was 9 pi square units. I'm going to divide that by 2. Well, 9 divided by 2 gives me 4.5, so I've got 4.5 pi square units. This is the amount that was counted twice, right? So now I need to subtract that out from the 46.27 that I just got. So 46.27 minus my 4.5 pi square units, that's the amount that got counted twice. All right, so subtract 4.5 pi. All right, and so I'm getting approximately, and again, this is rounded, 32.14 square units. Okay, now the other method that we could have used there, and this is probably the one that I would have done, instead of thinking about subtracting out the half that got counted twice, I could have just never included that amount in the first place. And so when I looked at this problem, I thought of it as a whole rectangle here with an area of 18 square units plus half of a circle that was placed on top of it, right? So if I think of it as just a whole rectangle and then a semicircle on top, for the area of my semicircle, I would start by dividing this by 2, which would give me an area of 4.5 pi square units. And then I could just take that 4.5 pi square units, that's the half of a circle up here on top, and add it to the 18 square units that represent the rectangle on the bottom. And if I do it that way, I don't have to worry about trying to subtract anything out, and I think it makes it a kind of a shorter, easier problem. So we had 18 square units from the rectangle on the bottom, plus 4.5 pi square units from the semicircle on top. And if I add those together, I'm still going to get 32.14 approximately square units for the area of that whole figure.